Developed as the world's first commercial jet airliner, the de Havilland DH.106 Comet had all the makings of aviation's future, presenting speed, comfort and performance that far outstripped the propeller-driven contemporaries of the Douglas DC-6 and Lockheed Constellation, and could have been Britain's barnstorming step towards a major stake in the post-war global market. Sadly, the Comet, being at the cutting edge of technology, also faced the terrible realities of entering uncharted territory, with multiple examples being destroyed in fatal crashes, most famously attributed to the then largely unknown phenomenon of metal fatigue. And though a revised Comet did ultimately emerge at the end of the 1950s, jet aviation dominance had been well and truly handed to the Americans, thus sparking the beginning of the end for Britain's commercial aviation industry. The origins of the Comet can be traced directly to the formation of the Brabazon Committee on March 11, 1943 by the British Cabinet, with this committee, chaired by Lord Brabazon of Tara, being tasked with determining what types of civil aircraft Britain would require once the war ended, with Great Britain having invested heavily in wartime aviation technology and possessing considerable expertise in aircraft design, though there was widespread concern that the United States would dominate the global civil aviation market after the war due to its powerful industrial capacity and successful piston-engine transport such as the Douglas DC-3 and Lockheed Constellation. The committee therefore sought to ensure that Britain would enter the post-war airline market with technologically advanced aircraft capable of competing internationally, with one of the committee's key recommendations being the development of a pressurized transatlantic mail plane capable of carrying approximately 1 long ton of payload at a cruising speed of around 400 miles per hour. During the committee's deliberations in 1943, the concept that eventually became the Comet was designated as the Type 4 aircraft within the Brabazon program, with the specification envisaging a high-speed transport capable of operating at around 30,000 to 40,000 feet and carrying roughly 24 passengers in addition to mail. Although the original concept emphasized mail carriage rather than passenger transport, it quickly became apparent that a high-speed pressurized aircraft of this type could form the basis for a revolutionary passenger airliner, with this idea emerging at a time when jet propulsion had just begun to demonstrate its potential in military aircraft. De Havilland, one of Britain's most innovative aviation companies, recognized the significance of these developments and began investigating the application of turbojet propulsion to civil aviation. And while many aviation authorities at the time believed that jet engines consumed too much fuel and were too unreliable for long-distance airline service, Sir Geoffrey de Havilland, the founder and head of the company, was convinced that jet propulsion represented the future of high-speed air transport. As a member of the Brabazon Committee, he used both his influence and his company's technical expertise to advocate the development of a pure turbojet-powered airliner rather than a conventional piston-engined aircraft, with this proposal challenging prevailing assumptions but offering clear theoretical advantages, with jet engines producing continuous thrust, being smoother in operation than piston engines, and performing especially well at high altitudes where thin air reduced drag. The committee eventually accepted de Havilland's proposal and incorporated the jet airliner concept into the Type 4 requirement, and in February 1945, the British government, through the Ministry of Supply, awarded a development and production contract to de Havilland under the designation Type 106, with this project representing one of the most ambitious civil aircraft programs attempted anywhere in the world. With no existing turbojet designs having been designed specifically for a civil transport capable of cruising at 40,000 feet with sufficient range to operate intercontinental routes, de Havilland faced the unusual task of designing both the aircraft and its engines simultaneously. While configurations varied from a near-total mail plane concept with seating for only 6 passengers to a dedicated passenger airliner with roughly 24 seats that would better satisfy the anticipated needs of post-war airlines. The strategic motivation for pursuing such an advanced design was partly economic and partly political, with British policymakers believing that aircraft manufacturing could become one of the nation's most important export industries after the war, and by creating a revolutionary jet airliner before any competing nation, Britain hoped to establish a technological lead that would translate into large international orders. The program therefore carried a degree of national prestige, with Duncan Sands, the Minister of Supply, later emphasizing that Britain had a rare opportunity to secure a dominant role in global aircraft manufacturing if it successfully developed advanced civil aircraft during the immediate post-war period. Another reason for pursuing the jet airliner concept was the expectation that jet propulsion would dramatically shorten journey times, with conventional piston-engined airliners cruising at roughly 300 miles per hour and were constrained by weather conditions at lower altitudes, while a jet aircraft capable of flying above 30,000 feet could travel significantly faster while avoiding much of the turbulence encountered by lower-flying aircraft. This advantage was particularly attractive for long-distance routes operated by Britain's overseas airlines, especially the British Overseas Airways Corporation, or BOAC, which connected the United Kingdom with destinations throughout the Empire and beyond, with BOAC quickly recognizing the potential of the proposed jet airliner and participated actively in discussions about its design, though despite the airline initially expressing an interest in purchasing 25 aircraft, the firm order placed in December 1945 was reduced to 10 units as the scale and cost of the project became clearer. In 1946, de Havilland assembled a design team led by Ronald Bishop, the chief designer who had previously been responsible for the successful Mosquito fighter bomber, with Bishop and his engineers exploring numerous possible configurations for the new aircraft, with some early studies considering highly unconventional arrangements, including canard layouts and tailless designs with swept wings and rear-mounted engines. The Ministry of Supply even ordered 2 experimental DH-108 aircraft with tailless swept wings to investigate the behavior of such configurations at different speeds, with the DH-108 prototypes demonstrating both the promise and the dangers of radical designs, as they proved unstable and were involved in several accidents during testing, with their experience ultimately encouraging de Havilland and BOAC to adopt a more conservative approach for the commercial aircraft. The configuration that emerged by September 1946 was considerably more conventional, but still technologically advanced, with Bishop selecting a low-wing cantilever monoplane layout with a wing swept back by approximately 20 degrees, while the fuselage was enlarged to accommodate 36 passengers, seated 4 abreast with a central aisle, a considerable increase from the earlier 24-seat concept. The aircraft would be powered by 4 turbojet engines buried in the wing roots, an arrangement chosen to minimize aerodynamic drag and reduce the problems associated with asymmetric thrust if an engine failed. And while the initial design was expected to use Rolls-Royce Avon engines, due to these power plants not yet being ready for operational use, the aircraft was eventually equipped with de Havilland's own Ghost turbojets as an interim solution, and in December 1947, the aircraft received its official name of the Comet. De Havilland began constructing wind tunnel models, full-scale mock-ups, and specialized testing equipment to evaluate the new aircraft's structure and systems, with the Comet incorporating many features that were unprecedented in civil aviation, including a fully pressurized cabin, integral fuel tanks within the wings, powered flight controls with artificial feel, and extensive use of metal-to-metal bonding adhesives such as Redux. These innovations required an unusually comprehensive research and testing program, and at de Havilland's home of Hatfield Aerodrome, the company built a decompression chamber large enough to contain sections of the fuselage so that engineers could simulate the pressures and temperatures encountered at very high altitudes, while structural components were subjected to repeated stress cycles to determine how the aircraft would behave over thousands of hours of airline service. The development of suitable turbojet engines formed another crucial part of the program, with the de Havilland Ghost engine, which would power the first production Comets, undergoing extensive ground and flight testing during the late 1940s, with experimental installations on modified Avro-Lancastrian aircraft accumulating hundreds of hours of flying before the Comet itself entered flight trials. Additional testing was performed using a Vampire jet fighter equipped with the same engines, allowing engineers to study performance at altitudes exceeding 59,000 feet, with such trials demonstrating that the engines could operate reliably in extreme conditions and were capable of providing the thrust required for the new airliner. Inside the aircraft, the passenger cabin represented a significant departure from contemporary airliner interiors, with the Comet being approximately the length of later narrow-body airliners such as the early Boeing 737, but carrying far fewer passengers in order to maximize comfort, with early configurations installed by BOAC, including 36 reclining slumber seats, arranged 4 abreast with generous spacing between rows. Large rectangular windows provided wide views outside the aircraft, while onboard amenities included a galley capable of serving hot meals, a bar area, and separate lavatories for men and women, while the cockpit accommodated 2 pilots, a flight engineer responsible for monitoring mechanical systems, and a navigator who operated specialized navigation equipment from a dedicated station. Irreversible powered flight controls were introduced so that aerodynamic loads acting on the control surfaces could not feed back through the control system to the pilots, improving both safety and ease of operation at high speeds, while multiple hydraulic systems powered key functions including the landing gear, control surfaces, de-icing equipment, and cabin pressurization. The first prototype, designated Golf 5-1 during early testing and later registered Golf Alpha Lima Victor Golf, was completed at Hatfield in 1949, and on July 27th of that year, the aircraft made its maiden flight, as piloted by de Havilland's chief test pilot, Group Captain John Cat's Eyes Cunningham, a distinguished wartime night fighter pilot, while accompanying him were co-pilot Harold Tubby Waters, engineers John Wilson and Frank Reynolds, and flight test observer Tony Fairbrother. The first flight lasted 31 minutes and involved basic handling evaluations at altitudes up to and around 10,000 feet, with Cunningham later reporting that the aircraft handled smoothly and demonstrated excellent controllability both in the air and on the ground. And over the following weeks, the prototype conducted dozens of sorties, sometimes completing 5 flights in a single day. Altitudes exceeding 43,000 feet were achieved, while shallow dives approached Mach 0.8, and the aircraft demonstrated the ability to cruise at roughly 490 miles per hour at 40,000 feet, almost twice the speed of the most advanced piston engine transports, while during this period, the Comet also undertook several record-setting demonstration flights, including rapid journeys from London to Rome and Cairo. A notable trip from London to Tripoli in October 1949 averaged more than 430 miles an hour, and by the time of its public debut at the 1949 Farnborough Air Show, the aircraft had accumulated more than 300 hours of flight time with minimal modification, while a second prototype, Golf Alpha Lima Zulu Kilo, joined the program in July 1950. This aircraft was used primarily for airline training and route-proving trials, and in April 1951 it was transferred to the Comet unit operated by BOAC at Herne Airport, where airline crews accumulated approximately 500 hours of experience flying the new jetliner on simulated passenger routes, with these trials including long-distance flights to Johannesburg, Delhi and Singapore, while airlines around the world closely observed the program, with engineers from Qantas attending demonstrations in order to assess the aircraft's performance and reliability. The first production Comet, registered Golf Alpha Lima Yankee Papa, flew on January 9, 1951, with the production aircraft incorporating several improvements over the prototypes, including 4-wheel bogey main landing gear instead of the earlier single-wheel arrangement, with the type receiving its first certificate of airworthiness on January 22, 1952, roughly 6 months ahead of schedule. The Comet 1 was powered by 4 de Havilland Ghost turbojet engines, each producing around 5,000 pounds of thrust, and the aircraft had a wingspan of 115 feet and a fuselage length of approximately 93 feet, and could carry between 36 and 44 passengers in spacious surroundings that emphasized comfort and quietness. The jet age of commercial aviation effectively began on May 2, 1952, when Golf Alpha Lima Yankee Papa departed London on the world's first scheduled jet airliner flight, carrying fare-paying passengers to Johannesburg via Rome, Beirut, Khartoum, Entebbe and Livingston, with the journey demonstrating the dramatic advantages of jet propulsion, as flight times were approximately half those of comparable piston-engined aircraft. During its first year in service, the Comet appeared to fulfill all expectations, with BOAC operating 9 aircraft, and by the summer of 1953, 8 Comets were leaving London each week for destinations including Johannesburg, Tokyo, Singapore and Colombo, while in August 1953, the London to Tokyo route took 36 hours, compared with more than 80 hours on earlier piston-engined aircraft. Passenger demand was strong, and the aircraft could operate profitably with relatively low load factors, and within a year, the fleet had carried around 30,000 passengers, with the Comet's smooth jet flight, reduced maintenance costs, and ability to cruise above 30,000 feet, giving Britain a perceived technological lead of several years over other aviation powers. The Comet's early commercial success also attracted international interest, with Air France and the French airline Union Aéromaritime de Transport, or UAT, each ordering 3 Comet 1A aircraft, a slightly improved version with greater fuel capacity for services to West Africa and the Middle East, while Canadian Pacific Airlines ordered 2 examples, and several other airlines expressed interest in future variants. Plans were underway for larger and more capable models, including the Comet 2 and the even more ambitious Comet 3, intended for long-range transatlantic services, and at this stage, the aircraft seemed poised to dominate the emerging jet airliner market. However, a series of accidents soon interrupted this promising start, with the first serious incident occurring on October 26, 1952, when a BOAC Comet departing Rome failed to become airborne and ran off the runway, although no fatalities occurred. While on March 3, 1953, a Canadian Pacific Comet 1A crashed during a takeoff attempt at Karachi while on a delivery flight to Australia, killing all 11 people aboard. Investigators initially attributed both accidents to pilot error, concluding that over-rotation during takeoff had caused the aircraft to stall, and as a precaution, de Havilland modified the wing leading edge with a distinctive droop and added wing fences to improve low-speed aerodynamic behavior. Sadly, a far more serious accident occurred on May 2, 1953, when BOAC Flight 783, a Comet 1 registered Golf Alpha Lima Yankee Victor, disintegrated in a severe thunderstorm shortly after departing Calcutta, killing all 43 people aboard, with witnesses reportedly seeing the aircraft plunge to the ground in flames, apparently without its wings. The Indian government convened a court of inquiry that recovered much of the wreckage and reconstructed it at Farnborough, with investigators concluding the aircraft had encountered extreme turbulence that imposed severe negative G-forces, causing structural failure of the horizontal stabilizer, and though the inquiry did not identify metal fatigue as a factor, it recommended operational changes including stricter speed limits in turbulence and the installation of weather radar, while also introducing a Q-field system that provided artificial control feedback so that pilots could better sense aerodynamic loads through the control column. Despite these precautions, the most catastrophic events in the Comet's history occurred in 1954, when on January 10th of that year, BOAC Flight 781, as flown by the first production Comet Golf Alpha Lima Yankee Papa, departed Rome's Ciampino Airport for London, but broke up in mid-air over the Mediterranean near the island of Elba 20 minutes after takeoff, killing all 35 passengers and crew. As there were no witnesses and little initial evidence, investigators struggled to determine the cause, with the Able Committee examining possibilities ranging from sabotage and clear air turbulence to control flutter or engine failure, while the Royal Navy conducted an unprecedented deep-sea recovery operation that eventually retrieved approximately 70% of the aircraft's structure. BOAC temporarily grounded its Comet fleet while modifications were considered, and although the Able Committee's preliminary report suggested fire as the most likely cause, no definitive structural fault was identified, and as a result, Comet operations resumed on March 23, 1954, though only weeks later, disaster would strike again. On April 8, 1954, a Comet chartered by South African Airways as Flight 201 crashed into the Mediterranean Sea near Naples while flying from Rome to Cairo, killing all 21 people aboard, with the similarity between the two accidents immediately prompting the permanent grounding of the entire Comet fleet and the revocation of the aircraft's certificate of airworthiness. A new inquiry, known as the Cohen Committee, was established in October 1954 to determine the cause of the crashes, and the investigation, led by Sir Arnold Hall of the Royal Aircraft Establishment, became one of the most exhaustive accident investigations in aviation history, with engineers reconstructing large portions of the Elba wreckage at Farnborough and subjecting a complete Comet fuselage to repeated pressurization cycles inside a large water tank specifically built for the purpose. On June 24, 1954, after more than 3,000 simulated flight cycles, the fuselage burst open, revealing a fatigue crack that had initiated at a bolt hole near an escape hatch and propagated through the fuselage skin, while further analysis of the recovered wreckage revealed a similar fatigue crack originating at a rivet hole in the corner of an automatic direction finder antenna cutout above the cockpit of the Elba aircraft. The repeated pressurization cycles experienced during normal flight had produced stress concentrations around these openings in the thin fuselage skin, and over time these cracks grew until the structure failed catastrophically, causing explosive decompression and the rapid disintegration of the aircraft, with Golf Alpha Lima Yankee Papa, before its loss, having completed 1,290 pressurized flights, while the South African aircraft had completed around 900 cycles, both within the range where fatigue failure could occur. The findings demonstrated that the Comet's pressurized cabin had been subjected to stresses greater than originally anticipated, and that the concept of metal fatigue in pressurized aircraft structures had not been fully understood, and although the aircraft's passenger windows were often mistakenly blamed, the inquiry determined that the critical failure occurred at the ADF antenna cutouts in the roof above the cockpit rather than at the passenger windows themselves. Nevertheless, the investigation revolutionized aircraft design practices, and future aircraft would incorporate thicker fuselage skins, stronger structural frames, and fail-safe design principles intended to prevent small cracks from propagating catastrophically. As a result of the inquiry, all Comet 1 and 1A aircraft were withdrawn from service and returned to Hatfield, where many were used for further testing or scrapped entirely, while de Havilland began redesigning the aircraft with thicker structural skins, reinforced fuselage frames, and modified window shapes that were easier to bond using adhesive techniques. Meanwhile, development of improved Comet variants continued, with the Comet 2, originally intended for BOAC, incorporating a slightly larger wing, increased fuel capacity, and more powerful Rolls-Royce Avon turbojet engines, each producing around 7,000 pounds thrust, while its fuselage was slightly longer than that of the Comet 1, and the aircraft was designed for longer routes including transatlantic operations. However, following the grounding of the Comet 1 fleet, airline orders for the Comet 2 were cancelled, and most completed aircraft were instead delivered to the Royal Air Force beginning in 1955, and in RAF service, they were designated Comet C2 and used for transport, training, and specialized electronic intelligence missions. The next stage of development was the Comet 3, which represented a substantial enlargement of the design, with its fuselage being lengthened by over 15 feet, enabling it to accommodate up to 78 passengers, and it was powered by even more powerful Avon engines producing around 10,000 pounds thrust, and the aircraft also incorporated additional wing fuel tanks to increase range. The prototype Comet 3, registered Golf Alpha November Lima Oscar, first flew on July 19, 1954, though due to it having not yet incorporated the full structural modifications required after the accident investigation, it was tested in an unpressurized state, but nevertheless played an important role in demonstrating that the Comet concept remained viable and in preparing the way for a completely redesigned production model. Throughout the mid-1950s, the Comet 3 served primarily as a development aircraft and a publicity platform intended to restore confidence in the program, and in December 1955, it undertook a widely publicized round-the-world tour flown by John Cunningham, visiting destinations including Sydney and Honolulu, with the tour demonstrating the aircraft's reliability and performance and helping to persuade airlines that the Comet could return to commercial service safely. The ultimate outcome of these developments was the Comet 4, which incorporated the lessons of the accident investigations and the improvements introduced with the Comet 3, with the fuselage structure being extensively reinforced with thicker skins and redesigned cutouts, the fuel capacity being increased, and the powerful Avon engines providing greater range and improved takeoff performance, while the aircraft also benefited from the operational experience gained with the earlier variants. The Comet 4 made its first flight on April 27, 1958, and received its certificate of airworthiness on September 24th of the same year, with the first production aircraft being delivered to BOAC the following day, while on October 4, 1958, BOAC inaugurated the world's first regular jet-powered transatlantic passenger service between London and New York using the Comet 4, although westbound flights still required a fueling stop at Gander in Newfoundland. Although the Comet 4 restored Britain's presence in the jet airliner market, the delay caused by the accidents allowed American manufacturers to catch up and surpass it, and by the end of 1958, Pan American World Airways had begun operating the Boeing 707 on transatlantic routes, and the larger, faster American jetliners soon proved more economical than the Comet. The Comet 4 series typically accommodated between 74 and 81 passengers, a considerable increase over the original Comet 1's 36 to 44 seats, and the Avon engines produced more than twice the thrust of the earlier Ghost turbojets, giving the aircraft better takeoff performance, higher cruising speeds, and greater range. During the early 1960s, the Comet 4 remained in active service with several international airlines, with BOAC continuing to operate the type on various long-distance routes, although by 1959 it had already begun to transfer many of its transatlantic services to Boeing 707s, which were better suited to high-capacity North Atlantic operations. As a result, BOAC increasingly redeployed its Comets to other routes and leased some aircraft to associated carriers including Air Ceylon, Air India, Central African Airways, Araya Ecuador, and Qantas, while Aerolíneas Argentinas became one of the most prominent overseas operators, receiving 6 Comet 4 aircraft between 1959 and 1960 and employing them on services from Buenos Aires to Santiago, New York, and various European destinations. East African Airways took delivery of 3 new Comet 4 aircraft between 1960 and 1962 and used them to connect East African cities with London and regional destinations such as Kenya, Tanzania, and Uganda, while at the same time, the Comet 4B entered service with BEA in 1960, with this variant having been originally designed for the American carrier Capital Airlines, but when Capital was absorbed by United Airlines, the aircraft instead entered production for BEA with a stretch fuselage capable of accommodating up to 99 passengers. BEA used the type primarily on medium-range routes such as London to Tel Aviv and other European and Middle Eastern destinations, while Olympic Airways was the only other airline to order the 4B variant, though another important version, the Comet 4C, first flew in October 1959 and entered service in 1960 with Mexicana de Aviación. The 4C became the most widely sold Comet variant and was purchased by airlines including Kuwait Airways, Middle East Airlines, Misrair, later Egypt Air, Sudan Airways, and the Saudi Royal Flight, with the combination of the longer fuselage and extended wing fuel capacity giving the aircraft improved range while retaining good performance from high-altitude airports such as Mexico City. Throughout the decade, the Comet continued to operate widely across Europe, the Middle East, Africa, and parts of Asia and Latin America, with aircraft from airlines such as Malaysia Singapore Airlines and United Arab Airlines being frequently seen at major international airports, though as the economic realities of airline operation increasingly favored larger jetliners with higher seating capacity, American aircraft such as the Boeing 707 and Douglas DC-8 were more capable of carrying far more passengers over longer distances at a lower cost per seat. As these aircraft entered service in growing numbers during the early 1960s, the Comet gradually lost its position as a premier long-range airliner. But despite declining commercial sales, the Comet continued to find important roles throughout the decade, with several Comet II airframes originally intended for civil use having already been transferred to the Royal Air Force after the grounding of the early Comet I fleet. These aircraft served primarily with No. 216 Squadron as jet transports carrying passengers, medical equipment, and VIP personnel, while other examples were converted for specialized electronic intelligence duties with No. 51 and No. 192 Squadrons, monitoring Warsaw Pact radio and radar transmissions during the Cold War. Another significant development of the decade was the transformation of the Comet into the basis for a new maritime patrol aircraft, with the two final Comet 4C airframes being modified as prototypes for a new Royal Air Force requirement and were designated the Hawker-Siddeley Nimrod. And although the Nimrod would become a distinct aircraft with major structural changes and new avionics, its origins were clearly visible in the Comet's fuselage design and general configuration. The Nimrod program began development during the late 1960s, and the aircraft entered service with the RAF in 1969, marking the culmination of the Comet's evolution into specialized military roles, while commercial production of the Comet 4 series continued until 1964, by which time a total of 76 aircraft of the Comet 4 family had been delivered since the type's introduction in 1958, and a total of 114 Comet airframes overall since the program began in the 1940s. By the middle of the decade, the aircraft's role with its original launch customer was drawing to a close, and in November 1965, BOAC formally retired its Comet 4 fleet from revenue service, replacing them with more modern aircraft better suited to the airline's long-haul operations, though this did not mark the end of the type's operational life. Many Comets were transferred to other airlines or leased to smaller operators, beginning a second phase of service that would extend well beyond the 1960s, and among the companies that would later operate the aircraft extensively was Dan Air, which eventually acquired a large proportion of the remaining airworthy civil Comets and operated them primarily on inclusive tour charter flights. From around 1970 onwards, the Comet's commercial service gradually declined as airlines replaced it with more modern jetliners offering greater capacity and efficiency, and the final scheduled commercial passenger flights of the Comet ended in 1981, bringing nearly 3 decades of airline service to a close. Even after its withdrawal from airline service, the Comet continued flying in experimental roles, with several aircraft being employed by British government research establishments for testing radar, avionics, and automatic landing systems, with one such aircraft, Comet 4C X-ray Sierra 235 Canopus, serving for many years as a research platform, making its final documented flight on March 14, 1997, and thus rounding out the last sortie of any Comet airliner into the sky. Perhaps the most significant continuation of the Comet's legacy emerged through its transformation into the Hawker-Siddeley Nimrod maritime patrol aircraft, which eventually evolved into several variants used for maritime surveillance, search and rescue, and signals intelligence, with this derivative of the Comet remaining operational until 2011, more than 60 years after the original Comet prototype first flew. In the end, while the Comet is more well known for its slew of accidents, its influence on aviation extended far beyond its operational career, with its development and subsequent accident investigations profoundly affecting aircraft structural engineering, with the recognition of metal fatigue in pressurized fuselages leading to the adoption of new design standards, more extensive fatigue testing, and the introduction of routine non-destructive inspection techniques such as radiography and ultrasonic testing, practices that have become standard across the aerospace industry. The aircraft also demonstrated the commercial potential of jet transport, with its quiet, smooth cabin environment and high cruising altitude offering a level of comfort and speed previously unattainable in civil aviation, with rival manufacturers such as Boeing and Douglas studying both its achievements and its failures when designing their own jetliners. Therefore, while the Boeing 707 and Douglas DC-8 may have democratized the concept of air travel by bringing fast, smooth, and efficient jet transportation to the masses, it was the quiet innovation of the Comet that proved that the concept truly had merit, And although this machine was beset by the burdens often experienced by cutting-edge technology, one cannot deny that the Comet, for a brief shining moment between 1952 and 1954, was by far the most advanced airliner in the world, and appeared to have set Britain on a course for market dominance and technological supremacy.